This is Algebra 1, Semester 2. It's the third unit on quadratics. It's the seventh lesson on graphing x squared plus bx plus c practice. It's on creatormath.com or creatormath.weebly.com, and it's under the Algebra tab. The instructions are: copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. So this one says use Desmos to graph both function options below and choose the pair which represents the graph. So we're going to use, part of quadratics is being able to understand the graph of the parabola and identify parabolas that are the drawing for a given function. And that's what we're going to try to do now with this lesson. Before I go there, let's bring up, make sure you can get to creatormath.com. Go here, let's just show the home page. And just while I'm here, it's creatormath.com or creatormath.weebly.com, whichever works for you. Type it into Google, leave no spaces. I just wanted to scroll down here and show some of my students who are online now. There's the composition book picture. Go under that, and if you're struggling to see where these composition book due dates are, they're down right here. As you're watching this video, it's probably not the right dates for you, so don't worry about that. Just go here to find those dates, okay? So this one we're doing is the 5th week. Follow that instruction and that date for turn-in. Then the other thing would be, where's the notes? We're going to go to the Algebra tab, because this is algebra. We're in the 3rd unit, so here's the table. Pass by, this is vocabulary up here, and there's your vocabulary PDF with all the vocabulary on it. Pass by the vocabulary. We're in Semester 2. This is the table of contents. This is what goes on pages 2 through 6 of your comp book. Here's all the page numbers, and you copy all this into pages 2 through 6. Here's exponents and polynomials, modeling two variable data, and we're in quadratics. We're all the way down in this lesson here, graphing x squared plus bx plus c. This goes on page 67-68 of your comp book. Here's the notes. Make sure you can open those. And it's a picture of the board or a picture of my notes. For me, sometimes it takes a second or two to load. And sometimes I have to load it twice, you guys. It doesn't always come through. Like mine right here is not loaded yet. And if it does, it's still blurry. Once it loads, it'll have a high enough resolution for you to expand and see all the notes. All right, and sometimes I've had, just lately, let's see, 67-68. Let me do it one more time. Pull this up. There it goes. I just saw it load. Now I can expand it, and I can do all the notes on the right page of my comp book. All right, and it's going to talk about roots, which we're going to talk about right now, the vertex, and the y-intercept. Those 4 points that help us define a graph of a parabola according to its function. And I'm just kind of looking through here to see what else I'm going to talk about as I do this. Okay, so with that, we're also going to go we're also pulling up Desmos.com, and I'm going to show you this first one, and then I'm not going to show you this again because it takes a little bit of time to do, but you're going to do these on your own. In Desmos.com, you press graph, and it takes you to the graphing. We have a place we can enter here. This is the graph they're giving me now. It's a pretty long parabola. It almost doesn't fit on my screen. And here are my options for functions. So I'm going to plug in these functions and see which graph matches. And then I'm going to show you sort of how to run through the different graphs very quickly and look at the clues and figure out where the roots are, where the y-intercept is, and therefore match up the right function with the right graph. Right? Let's start with this. This one says f of x, that's function notation, equals x squared plus 6x minus 27. So on my calculator, I'm going to literally write f of x, which, here's an f. This is function notation, parentheses, x, parentheses, equals. That's what you have right here. X caret 2 is x squared. X squared. Notice it's already got a parabola drawn, but my parabola has some other parts to it. It's got plus 6x minus 27. Right? So it's showing me the roots right here, and as I expand this graph, I can go in closer and I can literally look at the different roots. Roots are where the parabola crosses the x-axis, also called x-intercepts. And notice when it was when I was expanded out, I couldn't quite see them, but as I zoom in, it'll show me where this point is. If I click on the point, it'll actually tell me that this root is at -9, 0. And I'm going to show you how to look at this right now and show that this is the right graph for it. We know this is the right graph for it already because we typed it in. And this is the same graph we're looking at here. Here's a root right here at -9. And the other root, if we scroll over to this side, expand this, tap on this dot right here, it's at 3, 0. This is the one we're looking at too. And I'm going along on this first one because it's going to take a while, but the others I'm going to speed through once we see the pattern. All right, and the other big thing is, where does it cross the y-axis? Let's scroll down here. See how the parabola crosses through or touches on the y-axis right there. I saw it. You see that point pop up there? There it is. It's at -27. If I click on it again, it says 0, -27. This is coordinate form, parentheses x, comma, y, right? -27. So we're going to start to identify why this is true for this parabola. And once we see the pattern of this first one, we're going to roll through all the others pretty quickly. All right, so the points where a graph crosses the x-axis have many names. This is here. We said it was at 3 and -9. These are called zeros, roots, and x-intercepts. Zeros, roots, and x-intercepts. There's a lot of different names for them. There's also a vertex of this parabola. The vertex is where the parabola changes directions from down and then starts going up. See this point right here? We're actually not going to calculate the vertex in this assignment. We're going to do it in a later one. We're going to focus on this point, which is where the graph crossed through the y-axis right here. We said it was -27. All right? So let's look at the actual function we typed in. We typed in f of x equals x squared plus 6x minus 27. It turns out that the location of where we cross the y-axis here is when the value of x is 0. Why? Because to be on the y-axis, we must be crossing right here, and if this is the x-axis, this has to be 0 in the x-axis. So x must equal 0 at this point here. So just imagine taking this function, and we say f of 0, we put in 0 for x, which is 0 squared, right, plus 6 times 0 minus 27. What do we get for this? This is 0. This is 0. We get f of 0 equals minus 27. That defines for us this location right here. So if you give me only one parabola and it's crossing the y-axis at minus 27, look at these others. This one crosses at 48. This one crosses at 45. This one crosses at negative 63. I already know these are all wrong. This one crosses at minus 27. So I already know this is the right function. Let's check two other points. Let's check the roots. So the roots here are 3 and minus 9. And what we have here is the factoring of our quadratic. And so we factor it to be x minus 3 times x plus 9. Remember the reverse of x minus 3, x plus 9. We use FOIL here first, outside, inside, and last. And again, this is in another lesson, so I'm just reviewing it here quickly. X times x is x squared. Outside is 9 times x is 9x. Inside is negative 3 times x, or minus 3x. Last is minus 3 times a positive 9, which is minus 27. We combine these middle terms. 9x minus 3x is 6x. Okay, so x squared plus 6x minus 27 is the function we're dealing with. This is the factored form. The factored form, because we're placing this equal to 0, in other words, if we say f of x equals 0, where is this parabola crossing the x-axis? It's where y equals 0. And since f of x is equal to y for us in this case, we're saying 0 equals this number. This takes us back to the zero product property, again covered in a different lesson, but now used here. This is where if we have 0 equal to a times b, either a is equal to 0 or b is equal to 0 or both. So we take both of these. We take x minus 3, put it equal to 0, add 3 to both sides. We solve for x, x equals 3. Notice that is the location right here of one of our roots. So that happens for this one, check. And guess what happens for this one? We have x plus 9 equals 0. We say minus 9, and we get x equals minus 9. So that's the location of the other root, right here. So we said that one was minus 9. So we know that this function graphs to this parabola, and we know that because of the different clues we have. And now we're going to roll through a bunch of other parabolas and just illustrate this happening over and over again. So you're going to graph this one, and you're going to put it into Desmos, but we're going to look just at the data. Here's our x-axis here. We've got something going on here. We have a root and a root. And if this is 10, 2, 4, 6, 8, 10, this must be 6 here, and this must be 8. So we knew that these reversed when we put them equal to 0. So the 6 is here, the 8's here, and look at this. Look at this tail, 48. Does this thing cross the y-axis at 48? Here it is, way up here, and it's crossing. This is every 2, 4, 6, 8, 10. So this is 48 right here. So that's why this parabola matches up with this function and its factored form. We find the roots, or where it's crossing the x-axis, and where it's crossing the y-axis. Let's look at another. 2, 4, 6, 8, 10. So every 2, 2, 4, 5. This looks like 5, and this looks like 9. So we're looking for x minus 5 times x minus 9. That's what the roots tell us. Sure enough, it's right here. That matches. We also see that if these were gone to 0, and this was gone to 0 because we're finding where x is 0, right? Then, where you have f of 0, actually, then this is going to cross the y-axis at 45. So let's go up and look. Is it crossing right here at 45? Here's 40, here's 50. It looks like it's going kind of hard to see. It looks like 2, 4, 6. This is right here at 45. Check. So that matches with this one here with a tail of 45, right? That defines for us where this parabola is crossing the y-axis. Let's go even quicker. Here we have the parabola crossing the y-axis at negative 50. See, negative 50, negative 60, negative 63. Check. That bears out. And it looks like we have a root of 7 and minus 9. Here's 0. Here's x. 2, 4, 6, 7. Check. 2, 4, 6, 8, 9. Negative 9. Check. That's the one. This is the function. And again, you're going to type them into Desmos to verify this. You do not need to do anything other than that to have this illustrated for you. All right, so if this illustration doesn't work very well, that's where you're going to go. Looks like we're crossing the y-axis way up here, 120. I can't tell, maybe 122 or 121 or something. Let's just look at our answer choices. We do have a couple here. All right, this one's 36, out. This one's negative 121, out. But these are both options because they cross at 121. They've really got us on this one, right? Well, now let's look at the roots. This would be crossing at x equal to minus 11, and there's 2 of them. So it looks like minus 11 and possibly 0 here. And I stand corrected. This is going to, we put this equal to 0. Let's go back a little bit. X plus 11 equals 0 because of the 0 product rule. Minus 11 on both sides. Get rid of the 11. X equals minus 11. There's only one answer here. And notice our parabola is touching right at, this must be 5, 10, 15, 20, right here at negative 11. How can there only be one root? Because the parabola is just barely touching at its vertex on the x-axis, right? So it's got to be this one because it's at negative 11. It can't be this one. This one's crossing at positive 11. So this one's out. This function is the function that is being illustrated by this parabola. And it just goes on and up, and we see that confirmation of where it crosses the y there. Here's another single answer. This one is crossing, let's go the reverse this time. Here we have, this looks like 10 right here. That must be positive 11. We have this root at positive 11. I know this because it's the reverse of the one we just did. If this is positive 11, it's got to be this one with x minus 11. Does it cross at 121? Yep, here's 120 and here's 121. There it is right there. Once we figure out the system, we can select which function aligns with which parabola very quickly. You're going to use Desmos to help you, desmos.com, to help with that at first. Here, let's look at the roots first. We have a root out here. It must be a plus 11 maybe? Here's plus 20. Here's plus 10 right there. So maybe plus 11. We have one back here. It looks like 5, 10, and it's hard to see, you guys. I'm sorry. So it's minus 11. I think I can probably see a lot better than you. Well, maybe not. The picture's pretty good right there. Well, you can't see this grid line there. Okay, and this one here. So negative 11 and positive 11, that's our roots. Where are we crossing the y? Looks like here. This is y coming down right here. Here we are at a minus 121 maybe. So we're looking for a minus 121. This is out, out, out. It's got to be this one. And a root of negative 11 and positive 11. Now we're looking at where it's crossing the x-axis here. It looks like a single root, one root, because it doesn't come down like this, right? It's high enough that the vertex is right on the x-axis, so one root. Looks like at negative 6. So we're looking for something that yields a root of negative 6 and only one of them. It's got to be this 1 to the power 2, because even if you had x plus 6 times x plus 6 equals 0, right? If you take either of these and you say x plus 6 equals 0, minus 6 minus 6, x equals minus 6. It doesn't matter if you do the same here, you get the same answer. That's why there's only one. Let's go up and see where it crosses. Does it cross at 36 on the y? Sure enough, right there, 36 right here, 35, 36. This is our answer. Two roots, we have a negative 5 and a negative 3. So we're looking for a positive 5 and a positive 3. We already know this is it. Confirm it by seeing where we cross at 15, the y-axis. Sure enough, right there on the y-axis, 15. I usually don't do this many problems. That's why I'm going even faster. All right, where do we cross the y? We're already up here at 40. So we're looking for a plus 40 down here. Good. Where are our roots? We've got a 5 and 6, 7, 8. A 5 and an 8. So they're positive here. So remember, these reverse because of the zero property rule. So we're looking for an x minus 5, check, and an x minus 8, check. Number 11. We seem to have, let's see, a root. 1, 2, 3, no, it's by 2s. 2, 4, 6, 8, 10. So 2, 4, 6, 7. So this is at a plus 7. This is at a 2, 4, 6, 8, 10. So this is at a minus 9. So we're looking for an x plus 9 and an x minus 7. Let's go down and look. X plus 9, x minus 7. Check. We already know it's this one. The question is, does it cross at negative 63? Look right here, negative 60. 62, 63, right there. There we go. This is our the 3 clues right there. The only fourth point that we are not going to do in this lesson is the vertex. We'll do that in a later lesson. Those 4 points help us define parabolas very quickly. We could plot points all along this thing, but at this point, we're getting more efficient in our understanding of it, and we're going to find graphs more quickly. We're going to use fewer points, just those 4 points. So here's 2 roots, or zeros, or x-intercepts. This is where the graph crosses the x-axis. We have 2, 4, 6, 8, 10. This is 9, so we have a plus 9. and we have 2, 4, 6, 8, so 7, so minus 7. There it is right there. So we're looking for an x plus 7, it reverses, and an x minus 9. X plus 7, x minus 9. We know this is it. Let's just confirm. Are we crossing the y-axis at negative 63? Here's negative 60, 62, 63. Check, right there, 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 and there. All 3 points match up from the drawn parabola. So, match up the title, Algebra 1, Semester 2. It's the 3rd unit called Quadratics, and the 7th lesson called Graphing x squared plus bx plus c, which is a quadratic practice. And it's on creatormath.weebly.com under the Algebra 1 tab on the table of contents.